Consider your earliest years, a period rich with first experiences. Despite witnessing your initial moments of life, you retain no conscious memory of them. Most people simply assume your brain wasn't developed enough back then. But the actual explanation is far more intricate than that. Your infant mind wasn't failing to register events. It was actually capturing everything. Those early memories existed, yet something caused their disappearance. In 1905, Sigmund Freud was the first to formally identify this specific phenomenon, labeling it infantile amnesia. We now understand that infants are indeed capable of forming memories. This was demonstrated by psychologist Carolyn Rovi Collier's ingenious experiment at Rutgers University in the 1980s. She attached a ribbon from a baby's ankle to a mobile suspended over their crib. The infants quickly discovered that kicking would make the mobile move, a discovery they clearly enjoyed. When these same babies returned days afterward, they exhibited clear recall, immediately resuming their kicking. Even 2-month-olds retained this memory for days, while 6-month-olds remembered for weeks. This confirms that infant brains can learn, store information, and retrieve it. However, these memories prove ephemeral, vanishing entirely by the time adulthood is reached. For many decades, scientists struggled to fully comprehend the reason behind this complete erasure. The initial aspect of the explanation lies in brain structure. The hippocampus, a small, curved region deep within your brain, serves as the primary mechanism for creating memories. This structure enables you to process real-life events, like a birthday, a chat, or a rainy stroll, and store them as distinct episodes for later mental review. In adults, the hippocampus collaborates with the prefrontal cortex to categorize, retain, and access these stored experiences. However, in infants, this critical system is significantly undeveloped. The neural pathways connecting the hippocampus and the cortex are still in their formative stages. Crucial areas, such as the dentate gyrus, a vital entry point for new memories, don't achieve full neural connectivity until sometime between 2 and 4 years of age. Thus, your infant brain could generate short-term recollections, but it lacked the adult brain's ability to transfer them into lasting long-term storage. Yet, this only explains part of the enigma. However, this explanation merely covers a portion of the puzzle. What comes next in our understanding of infant memory is even more astonishing. A groundbreaking discovery in 2014 by 2 neuroscientists in Toronto completely reshaped our perceptions of how babies form memories. Sheena Jocelyn and Paul Franklin, working at the Hospital for Sick Children, proposed a theory that initially seemed quite preposterous. They asked a profound question. Could the very mechanisms responsible for developing your brain simultaneously be responsible for erasing your early memories? Their hypothesis centered on the early years of life, when your hippocampus generates new neurons at an incredible pace, a process known as neurogenesis, which is vital for development. These newly formed brain cells are crucial for establishing the neural pathways and circuits you will utilize throughout your entire life. Yet, Jocelyn and Franklin suspected there was an inherent drawback. Each time a new neuron incorporates itself into an existing circuit, it inherently disrupts established connections. Crucially, these were the very connections that held your nascent memories, making them vulnerable to disruption. To investigate this, they conducted experiments using mice. When neurogenesis was artificially accelerated in adult mice, they began to forget previously acquired information. Conversely, when they deliberately slowed neurogenesis in infant mice, these young mice retained their memories for longer periods than their normal counterparts. The findings, subsequently published in the prestigious journal Science, revealed a profoundly counterintuitive conclusion about early memory. It suggested that your infant brain wasn't too immature to store memories. Rather, it was simply too engaged in the rapid process of growth and development. The intense proliferation of new neurons that constructed your brain simultaneously overwrote the memories already stored within it. Your earliest experiences weren't merely unsaved. Instead, they were lost because your brain was constantly building new structures and dismantling old ones, a continuous remodeling process. However, there's an additional layer to this phenomenon, perhaps the most peculiar aspect of all. To form what scientists term autobiographical memory, the ability to recall personal experiences where you are the central figure, you require something often taken for granted: a distinct sense of self. This need for a distinct self means understanding your existence as an individual separate from the world around you. It requires grasping that events are happening specifically to you, the unique person. In the late 1990s, developmental psychologists Mark Howe and Mary Courage identified this as a critically missing piece. They proposed that before roughly 18 to 24 months of age, infants don't recognize themselves as separate individuals. The classic test involves placing a red mark on a baby's nose and then showing them their reflection in a mirror. Before 18 months, babies treat the reflection as another child, not reaching for the mark on their own face. However, after 18 months, they typically do reach for the spot, indicating self-recognition. This moment, the birth of self-awareness, closely tracks with the earliest age at which autobiographical memories can form. Essentially, you can't remember being a baby partly because you, as you now experience yourself, did not yet fully exist. There was no internal narrator then, shaping experiences into a personal story belonging to a specific individual. This raises an uncomfortable question. If you had no continuous sense of self, and your brain physically rewired itself beyond recognition, is the infant in your old photographs truly you, or an entirely different individual? Perhaps it's someone who lived in the same body, but whose mind was literally disassembled and rebuilt neuron by neuron into the person you became. Beyond self-identity, there's another critical component to memory formation: language, a subject extensively researched by developmental psychologist Catherine Nelson. Nelson concluded that language doesn't merely describe our memories. It fundamentally structures them. Developmental psychologist Catherine Nelson, after years of research, concluded that language does more than just describe our memories. It actively shapes their very structure. Before you acquired speech, your experiences were merely raw sensory inputs, a kaleidoscope of sounds, textures, emotions, and light. Yet, without the organizing power of words, these vivid impressions lacked a cohesive framework to anchor themselves within your mind. However, once children begin to speak, and especially when adults engage them in conversations about past events, their capacity for forming lasting memories dramatically improves. Language provides a fundamental structure for memory, much like a skeleton. Without it, experiences are fleeting, like water without a container, present one moment and gone the next. This isn't merely theoretical. Psychologist Chi Wang at Cornell discovered that the age of your earliest recollection actually varies significantly based on your cultural background. In Western societies, where parents frequently narrate their children's experiences and encourage personal storytelling, first memories typically emerge around 3.5 years old. Conversely, among the Maori of New Zealand, whose rich oral traditions emphasize personal history, average first memories extend all the way back to age 2.5. In certain East Asian cultures, however, where early childhood narratives focus less on individual experiences, initial memories often begin closer to age 4 or even later. This striking evidence suggests that the cultural environment you grow up in profoundly influences how far back your memory can reach. So, when we piece it all together, here's what likely happened during your earliest years. Your hippocampus wasn't fully developed for long-term storage. And even as it matured, the rapid growth of new neurons actively disrupted existing memory circuits, while you also lacked a sense of self and the language to structure experiences. It wasn't a single factor, but rather a confluence of everything at once. Every human being shares this experience, leaving a black hole where their first years should be. The reason isn't that your early brain was too primitive. Instead, it was engaged in a task far more critical than mere recollection. It was in the profound process of becoming you, a transformation that, quite literally, necessitated the dismantling of the person who existed before. Reflect on this incredible journey of self-creation and share your thoughts below.